See those skills? Let's see, who shall I start off with? Okay, Ro, we'll start off with you.
Well, I'm not even joking. Something's wrong with my screen right now.
You don't see my beautiful screen?
I can see yours, but it's like I think I clicked on something and it like made it smaller. Hold on. So you might want to like call somebody else.
Oh, okay.
No, I swear I'm not lying. I'm trying to fix my. I swear I'm trying to fix my screen. Hold on. I just don't want to hold up the class. You know what I mean?
Okay, Sarah. Okay, so we have the very first one. What is the atomic number, Sarah?
Okay. I'm back.
I have no idea.
You have a periodic table, right?
Yeah.
Okay.
What are the numbers you wrote on the side of them?
What do you mean by what are the numbers I wrote on
Those
the side of
little
them?
numbers at the top you wrote in the corner?
Oh, we talked about this yesterday. You don't remember?
Oh, I probably logged off a little early.
See what happens if you log off? Anybody want to help her out?
Do you want to just revert back to me?
What was that?
I said you want to just revert back to me?
Okay. So,
All
wait,
right, so
first off, tell her what these numbers mean right here.
Whoa, like I thought you was just asking for the mass number.
Isn't that the new atomic mass?
Okay,
Or atomic number?
It is the atomic mass or the atomic is not the atomic number. Atomic
Okay,
mass or
sorry,
the what?
it's the
Mass number.
Mass number. Yes.
yeah, the mass number. So it'd be 36.
Got that. Thank you. Atomic mass. So it would be what did you say, David? Sorry.
I interrupted and I said 36.
36
Yeah.
for what?
For I asked if it was 36 for atomic mass.
Okay, so it's 36 for the atomic mass. Okay, what about the atomic number?
It's sulfur, right? Sulfur.
That's right, it's sulfur.
Okay. It
Is it
says
16?
16.
Okay, 16. And the
And the
atomic number
symbol
tells
is
us
F.
what? What does the atomic number tells us?
The atomic number tells you the number of protons.
Okay, the atomic number tells me the number of protons. What else does it tell us?
The weight.
It tells us the weight.
The element.
It tells us the element. That's correct. Okay, so let's talk about the mass number. What's the mass number?
36.
How'd you get 36?
The number on top?
That's right. The number on top is called your mass number. So this is this an isotope or is this an ion or is it an element? We're skipping down to the bottom. Going to the meat of the problem.
Ion and an isotope.
It is an ion and an isotope. All isotopes are written out this way. This is one way of writing it. Another way of writing it is putting the atomic number down here. I'll show you an example of that later on. But you'll see this more commonly. Okay, how many protons?
16? 16.
How many electrons?
14.
Electrons are
Or do you add
18.
18?
It would be 18 because we have the addition of two more negatives. And we know electrons are negatively charged.
So is that the 16 plus the 2 negative
That's
2?
correct. 16 plus 2, you got it.
How
Hey,
did
how
you
many
get 36?
neutrons? What's that?
20.
How did you get 36? For
How do you get 36 for what?
the Mass, atomic mass.
The atomic mass, because this is the new mass of this isotope. So an isotope is the same element, but it has a different mass. And this tells me my new mass.
The 3B tells you your new mass.
It's 36.
No, the 36. That's 36, not 3B.
Oh, okay. Yeah, I'm tripping.
You guys
All
are
right, continue.
confused
My
there.
bad. Continue.
Okay. And how many neutrons?
20.
20.
Good. Piece of cake? Okay, Karina. Now, since you asked all those questions, ready?
I think, yes, see.
Okay, so let's start. The atomic number.
6.
Okay. Okay, Sarah. The atomic mass.
Is it 13?
That's correct. Okay, Mr. Pharma. Don't make fun of my writing again.
No,
Let's
I'm
go
not. I'm
right
making
words here,
because I'm not to be wrong. All right, let's go. Atomic
Okay.
mass number.
The mass number.
Was it 13?
That is correct.
I don't know how I got that. I just copied the atomic mass.
Number of protons.
6. Is it
Number
6?
of electrons.
2.
Marisol.
Is it 17?
17?
10?
No.
Two.
What is it?
2.
It's 2. So how many electrons would carbon normally have if it was a neutral
6.
atom? It would have 6.
6.
So this tells me it's 4 plus. That means that we're removing 4 electrons. So if you remove 4 from 6, how many's left?
2.
2.
Okay. So neutrons.
7.
7.
7.
Okay. Now what is this?
An ion and an isotope.
An ion and an isotope.
It's an ion and an isotope.
I need the 27. I better.
Is that a 27?
That's
On top of that.
27.
Okay.
Yeah, it's a horrible 27, but it's a 27. Mr. Pharma. Don't make fun of my writing.
I'm not.
Oh, now Judy's doing it too. Okay.
Huh?
I said, now Judy's making fun of my writing.
It's a 7?
It is a 7.
Oh, okay. Got it. Ah, shit. That fucked up all my shit right there.
Hey, Judy.
Yes. Sorry.
Telling us you fucked up already? Tell
Yeah.
me, atomic number.
Are you asking me?
Yep.
12.
Maria.
No. Oh, just kidding. Sorry. I think I did that one right.
Yes.
Atomic mass.
Oh, atomic mass.
I'm not sure.
Okay. Tiffany, you want to
27?
help her out?
27.
27. How did you know I was going to call on you? Did you feel it? She felt the vibe. So Maria, the new mass is going to be what's listed over here on the left-hand side. So if it's superscript, meaning it's above, then it's going to be your new atomic mass. And it's also going to be your what?
Mass number.
Your mass.
Mass number.
Mass number. Okay, let's see. Who haven't I picked on yet?
Me, it's 12.
Okay.
Hey,
I was just trying to get it out the way.
Hey, Carissa, number of electrons.
12.
Veronica, number of neutrons.
15.
And what is it?
Isotope.
element.
Is correct. So what is one way that I can definitely know that it's an isotope?
Because the electrons don't change?
The electrons don't change, okay? What else? Does that mean anything to us? If electrons change, does that mean it's not an isotope? Or does that guarantee it's an isotope?
They have the same number of protons.
They have the same number of protons. Do the protons ever change if it's the same element?
No.
Mm-mm.
Okay. So
I
you guys
look
are
at-
convincing me. I'm not
I
sold
look at if
yet.
there's a,
was
I
that?
look at if the atomic mass is changed.
The
the
atomic
mass number.
mass has changed. So if I look at the periodic table and I see my atomic mass is different than what is on the periodic table, then that tells me immediately it's a
Isotope.
isotope. Red flag, right?
Mhm.
Okay, let's see. David, start back with you. Oh no, we have new people. Ooh, new people. I like picking on new people.
I have a question.
Joanna, welcome. Are you ready?
Dr. Henry, before we move on, can I ask a question?
Yes, but it'll cost you $17.
I don't have 17, I have 1.
Oh, that'll work. It's a bargain day.
To distinguish if it's an ion or not, what are we looking for?
A charge, right? Because
A
what is the
charge.
definition of an ion?
I don't know. Off the top of my head, I wrote down somewhere.
Charged particle.
Okay, charged particle or a charged. So if it has a plus or a minus, we should immediately know that it's what?
An ion?
There we go. Okay,
190 to 140.
Deandra. We'll start with you.
Okay.
Okay. So
Is this
atomic,
one?
atomic
Is this one
number,
supposed to be NB?
that's ND.
ND.
ND, not NB. That's different.
Indeed.
N as in Nancy, D as in Daniel.
Oh, it's 60.
Okay.
I don't even see that one.
See, I'm making you work that periodic table, right?
Oh yeah. I see
Okay,
it.
Joanna, since you ignored me at first. Hey, Joanna, you're gonna help me out. What is the mass number? Joanna B. She's still gonna ignore me. You're not gonna give me any love. Is that the way it is, Joanna? Okay. David. Atomic mass.
Atomic mass 140.
Ooh, Andy popped in. Perfect timing. Andy. Andy,
Doctor,
how are you?
good.
You gonna help us with this problem?
Wow, it's the same one with this morning.
No, it's a different one than this morning, but the same type of idea.
Yeah, I can learn again.
Did you say you got lost again?
No, I have to learn again.
No, you don't have to learn again. You should already know it, right? You did it this morning.
Yeah, my memory is not too good, that's why.
Which one are we on? Is it the mass number?
We are on the mass number. You gonna help him out?
Yeah, it'd be 140.
40.
Okay.
140.
Let's see.
Too small.
Okay, let's go.
See.
Veronica,
Yes.
number of protons.
The protons are 60.
Let's go, Nancy, the number of neutrons. I mean, electrons.
54.
Judy, the number of neutrons. Are you there, Judy?
140 minus 50. What? I can see.
Are you gonna tell me, Andy, you got it? 40, you said 40 minus 140 minus 60?
Give me 1 minute. I do calculating right now.
Okay. Well, while he's doing the calculation for that one, is it an isotope, an ion, or an element, or a combination?
Ion and isotope.
Ion and isotope.
It's 80.
Okay. That is correct.
Can I ask a question?
You can. It'll cost you.
All right, man. I'm willing to pay.
Okay.
Because I'm getting lost. So how'd you get 60 for your proton? Your proton.
You tell me.
That's what I don't get it.
So what do we know? The atomic number is what?
Oh, so it's the number of proton. Okay, so that makes sense.
Dr.
Our
Henry,
number is always the number of protons,
But then how do I get my electrons?
because you know that every element, when it starts out, has to be neutral, right? So how many electrons technically would you start out with? If protons are positive, Mr. Pharma, and I told you it has to be, an element has to be neutral. Before it's an ion, right? Let's say it's just an element. How many electrons would ND have?
I'm guessing that's what I'm trying to figure out.
Well, don't think too hard, because it ain't that hard. Neutral, positive. What is going to balance out? What's going to make 60 positive things become 0?
60 negative things?
That is correct. Isn't electrons negative?
I'm assuming they are, right?
Yeah, because we told you that, right?
Oh, okay. Where was I at when you guys told me that?
I don't know. Obviously, we're doing something that you weren't supposed to do away. You know? Okay. So we have 60 positive, 60 negative, right? So now this tells us that we're removing 6 electrons. So
Because of that 6 plus right there?
That's correct. Because of that 6 plus, that means we remove 6 electrons, because we know 6 electrons are negative, right?
Right.
So
So
for it to be
60
positive-
minus 6 is 54.
That is correct.
Okay. I'm not gonna get this on the test, but I understand what you're saying right now.
Okay. Well, you better send it for the test too. Otherwise, we're gonna have attach a shock collar to you.
And which one is on?
Okay, our last one. Let's do it. Mr. Pharma, I think I'm gonna save the good stuff for you later, so I'm gonna wait to give you that. Okay, so we're gonna go, let's go, Nancy, you start us off.
Atomic number would be 31.
Okay, let's go. Judy, mass number. Are you there, Judy? Yes.
Dr. Henry,
Yes.
yes, I'm right here. I actually had a question. Sorry, I'm gonna make fun of your numbers. Is that a 72 and a 3 plus?
That is a 72 and a 3 plus. I'm messing with my
Okay.
numbers.
I'm sorry, I just couldn't see it. So atomic mass is 72.
Okay.
I'm back.
Okay, Carissa, our mass number.
Okay, where are we at? Last one. The last one, our mass number is 72.
Deandra, protons.
31.
Okay, Sarah, electrons.
28.
Mr. Farmer. Not Farmer, Pharma. Number of neutrons.
I can't believe this. You were gonna let me die.
Oh, wait, hold on. So all I'm doing is I'm minusing 72 from
Repeat that.
so I'm minusing 72 from 60,
No, from 2.
Nope, not from 60.
59.
How did you get 60 at?
It's mass number minus proton.
We're in this last row right here.
So mass number, so 72 minus 28.
Nope, not the electrons.
Proton.
Is it
Oh,
72
31,
minus
okay.
31?
Yeah, sorry. So hold on, let me calculate that first.
It's 41.
All right, thank you. It's 41.
Boy, they're impatient. They're like, come on, get it
I know.
done. Hey,
They're just hating.
Is it
them.
an ion or is it an isotope or is it a boot?
Ion and isotope.
On an isotope.
Hey, piece of cake?
No.
Okay, we'll see. Okay,
I
I'm gonna
said
put some
no.
up
I
there
said
real
no.
quick. What was that?
I said no. It wasn't a piece of cake.
Excellent. I'm glad you said that. We're still gonna see. Okay, let's see. Okay, you guys, you're feeling it pretty good so far?
They will record it. 1 minute, 1 minute, 1 minute, 2.
Mr. Henry, we can't see your face.
You can't see my face?
No, just your head. There you go.
Oh, is that better?
I seen like 3 hairs like this. That's it.
It's like doing this. It was a rough day.
Talk to Mr.
Okay, you ready? You ready? So this is what we're gonna do. I'm gonna write some up here. I'm gonna send you guys to rooms, and then I want you guys to hash them out.
No one's gonna want me in their group.
Okay,
Perfect.
You don't get to pick.
Put them in my group. I'll help them.
You'll help them?
Yes.
So you got a request.
Thank you. I appreciate it.
Okay, so this is what, ooh, hang on, I do that. Oops. Okay. So you guys, we've already talked about this. Okay, so I wanted to tell you, you'll see some symbols or things like that. So if you see Z, that stands for atomic number, okay? And then often you'll see the term A stands for mass number. So you'll often see those, well, not often. Very rare you'll see them, but usually that's the symbol that they'll use for it. Another way of writing your isotopes is you have your symbol, you have your mass number, and then you have the atomic number written down here at the bottom. So that's another way that you may see it written. And then, as I told you, you'll also see it written like this. So just the symbol dash 12, and that's your new mass number. Okay, well, in this case, C12 is normal. Okay, piece of cake?
Mm,
Now, it shouldn't be that hard because all it is just showing you different ways that things are written. Right?
So the top number is what? Like,
Your mass number, right? Same
Mass
thing it
number.
was before. Top number is the mass number,
oh, okay.
right?
That's
It's
the same.
exactly the same thing. The only
Okay.
thing now, you'll also see, and it's really weird because most people don't do it, right? Because you always know your atomic number is always going to be the same. So most people don't write it. You only write the mass number. That's what most people do. But occasionally you'll see an old book, and this is the way they used to do it in the old days. Okay? And also when we get into nuclear reactions, that's a little different, right? So then it's written the same way. Again, the mass and your number of protons. But we start playing with some other things going in that case. Okay? Are we good?
Are we gonna have to know this?
You need to be familiar with it. I would know it, you know. Most things that I talk about, it's going to come up. You'll see it in a problem, at least one problem. I love when I see this. So do I have to know it? No, I'm just talking about it because I like to talk. Okay. Oops. So, oh, we already talked about this. You guys are already ahead of the game.
wait,
When we talked about why what was disproved in Dalton's theory? Well, they're subatomic particles, right? So that means that you can break down to even smaller things. And then we also know that not all atoms of an element are not all identical because we have isotopes of those, right? Piece of cake?
Yeah.
Okay, so everything in the periodic table was basically based upon carbon. Carbon kind of started everything, right? As we say, carbon's a whore. Okay, and so when we determined the average mass, it was based upon carbon, and we also established that carbon was carbon 12, right? Okay, isotopes. Remember when we were talking about the different isotopes of things and how they're added together to determine the real mass number? Do you remember that?
refresh my memory, please.
Okay, so here we have 3 different isotopes of neon. Do you guys have your periodic table available?
Yes.
Yes.
How much does neon weigh?
What does it weigh?
Yep.
20.180.
180.
20.180, okay? So if you look at this, this basically shows you the relative abundance of neon. So this is neon 20, this is neon 21, and this is neon 22. So let me write that down so you can see what I'm talking about, so you understand. So this is neon 20. This is neon 21. And then this is neon 22. Which one is most abundant?
I'm gonna say the 22.
Neon 20.
20, yeah.
Abundant.
20, right? Because it has the higher bar, right?
Okay.
Oh, okay. Yeah.
Okay, so
Abundant is the better.
yeah, the higher bar is the better, right? It has the most. So here, neon 20 is roughly like 90 something, right? Where neon 21 is down to like maybe 5. And then neon 22 is about 10. So that's like percentage. So we'll say 85, 5, and 10. And that add up to about 100, right? And so that's like percentage. So to get the mass or the atomic mass, what we would do is we would take all of them in consideration. This represents like 85% of what we have. This represents 5% of what we have. And this represents 10% what we have. So in this case, we'd multiply 20 by 85%, or we'd multiply by the decimal, which is 0.085.
0.085.
Plus 5%, which is times 21 plus 10%, which is 0.10 times 22. Now we may be a little off because, you know, I'm eyeballing that abundancy. So that's,
Henry, I have a question.
yep.
So when it comes to multiplying the mass, right? Or what are we doing? Yeah. Do we have to, we take the mass, right? Not the atomic mass unit?
Okay, say that again.
So you know how here we're multiplying the percentage, which is in decimal form,
Yeah.
with our the mass that's provided?
Yep.
So when it comes to finding the relative abundance, we don't take the mass number, or sorry, we don't take the atomic mass unit, we take the mass number, right?
It's the, you said we don't take the atomic mass unit,
Yeah.
AMU. So you're saying, no, you would take the AMU, right?
So not the mass.
So your mass number is the same thing. So, okay, so you're asking two different things. AMU is atomic mass units, right? AMU is the same thing as, so atomic mass units. So you'd be looking at here. Okay, so here, this here represents your mass number. It's the whole number, right? So you're actually going to take the AMU multiplied by that number, right? But you can get away with using the mass number because it is roughly the same thing.
Oh, okay.
Okay.
Got it. Mhm.
But if you're given the AMU, or they just call it U, the units, you want to use those because that's going to get you more exact. And I'll show you that here in a second.
Okay. So it depends on what we are given then.
Yes. You don't want to be pulling stuff out of your butt.
Okay. No, because I had some students ask me this from the morning session, and I was like, yeah, you can use the mass number provided there. So that's why I was asking the question.
Okay. Okay. Let's see. Okay. Now that you have the idea, here, we'll give you an example. So the natural distribution of the isotopes of boron is 19.9%, and that's boron 10. So in this case, you want to use the AMU, which is for units, or U. So you want to use the mass that they give you. So that's 10.0129370. And 80.1% of boron 11, which is 11.0093055. So how would we do this?
Tomorrow, during tutoring.
Oh man. Yeah.
Yeah, is not the answer to this problem.
So you okay?
Is this where the formula is AMU and you have to change the percent to a decimal?
That's right. So we have to change the percent into a decimal. So let's start with that.
Thank you, Dion.
So we just divide it by 100, right?
Yes.
Yes.
So we get, okay, Eileen, that's 0.119.
9.
Okay, so then what do we do with it? We're gonna do what with that decimal?
Multiply it by the U 10 point, the mass 0.129370.
Okay,
And you add.
What is this?
what was that?
Nothing.
You're gonna mess with me about my writing, aren't you?
No, I can read it.
Okay,
I just
so
don't
how
know.
many sig
reading.
figs should we expect out of this?
I'm guessing
3,
3,
3.
4.
Okay, see, he was trying to tell you guys the answer. Okay, and then how are we gonna use this?
You
Not
have
to you.
to get the decimal.
0.801.
Times,
11.0093055 U. And that's gonna be 3 sig figs too, so it's gonna be 8.2. Great.
okay,
11.0.
what did you guys get?
8.82. Because you get multiplied by. Oh shit. 8.82.
Okay,
The video breaks it down.
so when we add them together, what do we get?
$10.8.
10.81. Said it would be 10.8.
Seven,
1.81.
Yes.
81.
We'll use 3 significant figures.
Okay, and how does that compare to what you guys see on your periodic table? Oops, did I get carried away?
The same.
Oh no, I didn't. So if we did sig figs based upon addition,
That's right.
right?
It's the same, right?
You
Mhm.
Yep. So it'll be 10.81 units. Piece of cake?
Yes.
Okay. So you guys want to try the next one?
Sure.
Okay. So Carissa, we'll have you do it. Do those skills.
Wait, no, I have to do this. Give me a minute. Get a paper and draw, baby.
I do have to.
Oh, yeah, that's a good one, Mamita. I like that. What's it have on it?
It weighs
Oh, a choo-choo. A train and a airplane, you're right.
I like that one.
Okay. You mind? I'm gonna do my work.
You're gonna do your work. Okay, don't forget to try to spell your name. Oh, sorry, y'all. I didn't know I wasn't on mute.
That's okay. I love it. See your motivation there.
Four. 7. I wrote kind of big. 0.9 2 4 1 times 7. The 4 1. That's supposed to be you. Oh, hold on. The screen's in the way. I ran out of space. Hold on.
The screen's movable. You can move it. If you pull the corner, it'll move to the other. You can move it to the other side.
It's not moving.
If you go from the top bar, you can move it.
Oh, whoa. Oh, okay. There we go. Oh man, I did it. Excellent. Oh, that's what I did.
So I have a question for you before you get too far.
Yeah.
So this number, you have 0.759.
Oh no, it's supposed to be 0.0759.
Yep. So this number here would just be 0.457.
Yes.
Yes.
Okay.
Okay. And then we're going to go 1 times 7 1 6 0 0 0 1 6.483. And then add the
Fine.
Add those two together.
yeah, add 4.57 and 6.483 together.
Okay, so I do not want to hear any mess about my handwriting now.
I know, okay? I feel like you have a lot more practice than me on doing this.
I'm just giving you a hard time. So we have 0.47 and we're adding, you said 6.4, is that 53?
8.3.
83.
83.
Okay. So that's 0. That's 4. 9. So 6.940.
It matches.
You guys agree?
Yes.
Piece of cake?
So that's what, 4 6 feet?
That's right. 4 sig figs. That's correct.
We don't take out the 0.
We did have the 0. You see the 0 right there?
Yeah.
So that's 1, 2, 3, 4. So that 0 counts. Because we're saying
Okay.
we're that good. You know, it's like, right?
Dr. Henry,
Yes.
so is it only in multiplication and division where if it's a 5, you go with the number behind it and that is what determines whether that number is rounded up or down or stays the same?
What you for your
No, it happens in all the cases. So even with multiplication and division,
three?
if we have more than 3 significant figures, we take that number, the number that would give us our number of sig figs. So if we actually do the math here, right? I know that this is like 4.5 something, 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 right?
Yes.
Right? So let's just say that it's just for kicks and giggles. I can't remember what it is exactly. So if it was 3, 4, 7 right here, right? So then what we would do, we'd always take this number and determine whether or not we're going to round up or if we're going to leave it the same. If we're going to round this guy up or we're going to leave it the same. You understand?
Yes.
So since that's a 3, what are we going to do?
It stays the same.
Leave it the same. If it was a 9 here, what would we have done? If it was a 9 here.
It would 0.58.
That's right.
Would be 8. Yeah.
Okay, see good?
Yeah, so
All the
Dr.
breakdown, everything.
that first, the whole number behind the 5, it's a 4. So
Yeah. So behind it, it's a 4.
yes, so would it be 0.456? It wouldn't go up to 7?
No, it's because this is a 7, right?
Oh, yes.
Yeah. You're not going to drop it down because you're always going to, it either stays the same or it's rounded up.
Okay.
Okay? Questions, concerns? Cash. Okay? Excellent. Okay, so let's see. Oh, got carried away. Okay, so here's an example. We have tables, and this is what I was kind of telling you. So you have all of these ions that exist, right? So these are the 2 most common ions for hydrogen. So we have hydrogen 1 and hydrogen 2. So those are your 2 most common ions, and this is their mass, their actual mass, okay? And this is the abundancy, right? And so you do exactly the same thing. So let's see. Let's do sulfur. So you guys want to figure this one out? You have questions? Marcel, you got it?
I have a question. Are we getting the percentage and timesing it by the mass?
Isn't that what we've been doing?
Yeah, I had to go handle my kids real quick, so
Okay.
that's why.
So yes, you're right. We are getting the percentage and timesing it by the mass. But you want to change your percentage into decimal form.
Okay.
Okay? So I'm going to throw you guys in groups again. Is that cool?
Yes.
Take a picture of your table. And you guys know that you can open up your screen and you can make a whiteboard on your screen. Oh, you already got it. You printed them all out?
Yeah, I did.
Yeah.
Which?
So let's see. Okay, you guys ready?
Like final answer?
Yeah, give your final answer.
32.06.
32.06. Everybody got the same answer?
I got 32.07.
You guys did 32.07?
32.065.
7. Because it should be well 1 though.
Okay.
Did you get that?
Yeah, that's
You did? Okay. We have a question though.
I have an answer.
How do we know how many sig figs are going to be in our answer? Because the percentages have all different sig figs.
Okay. So how many sig figs do we have for that first one?
4.
4, right? For the second one, we technically have 2, so we wouldn't really care about this 1. So then it would be 0.25, right? And then
Okay.
the third one is how many? 3. So then we would round this up to 1.46. Is that correct?
Yes.
Let me do this so we have 30.35. We have 0.25. We have 1.46. And then we have, this is only one sig fig, right? 0.007. So the answer should have how many sig figs? Because we're adding it together, right?
4.
Where would I draw my line since I'm doing addition?
Before the 7?
Before the 7.
Okay. So then my answer is going to be what?
32.067.
Oh, it's para que wow.
Okay. So what number am I going to use to round?
The 7.
Okay, I'm going to use the 7 to round. So is the 7 greater than 5? Okay, so then my answer should be 32.07.
Okay.
So that would be the answer I would expect on your exam.
Wow.
Okay.
Piece of cake?
No.
Did somebody say nope?
So even though that's different than what's on the periodic table, because on the periodic table it's 32.06, we would go with that 32.07. Okay.
Yeah, we go.
That's what was throwing me off, because I got the 32.07 and then I looked at the periodic table and it was 32.06 and then I got confused. Yeah, because we all got the same answer. It's just we didn't know where
How to
we
round
were
it off.
supposed to round, if we were supposed to.
Yeah. Well, sometimes like this table, the table that you're given, these are like rough estimates. They're not exact, so they're going to be slightly off. And there's also a couple of other ions. I mean, a couple of other isotopes that exist as well too, and that's going to kind of change the number. So that 32 isotope, it isn't as big as it normally is, or the 35 one isn't as big as it normally is.
Okay.
In this case, so okay.
Hey, Jessica, we went over this in SI, right?
Yes, we did. You should be proud of it, Ro.
Yeah, I don't know, man. See, I'm saying something else.
You got this.
Okay. Piece of cake?
Yes.
Oh. I might have to drop this class.
Okay, so let's move on. I have my hands in a lot of pots, and so I'm getting updates on things real quick. Okay, so you guys, we know about the periodic table. Are you feeling good about the periodic table?
Mm-hmm.
Yes, no, maybe?
No.
Yeah.
Yes. Oh.
Okay, so we're going to go over it just in case to make you feel a little bit better, just a little bit, right? So the first thing that I wanted to say is that the periodic table was actually arranged and organized initially. It was kind of crazy at first, but it was arranged and organized by these two guys. And they did some of the naming and then they changed some names along the way. Okay, but then they start realizing it's better to organize them according to atomic number. And then they realized that there's all these nice trends that resulted from that. Okay. Okay, so here's your periodic table. Up top, these guys are called what? Numbers up here.
Groups.
That's right, they're groups. And then along the sides, the numbers that are on the sides on your periodic table are called
Periods.
periods. That's correct. So here in the US, we actually had broken it up into transitional metals and the what we call normal, right? So the A's represented the what would be our normal things, and then transitional metals were a hot mess. We recognized that, so we kind of broke them up separately. Now this has changed since we started using the IUPAC method of nomenclature. So the IUPAC uses just straight numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 for your groups. Okay. So, but occasionally you'll find a really old periodic table that will have the 1A, 1B, and then you go 3A over here, 4A, 5A, 6A, 7A, 8A. And then down here, you start off with 3, then it's 3B, 4B, 5B, 6B, 7B, and then it gets crazy here, okay? So you see this where it says 8B and then 1B, 2B, right? So this is the reason why we kind of avoid using this, because it gets stupid at a point, right? Okay. So mostly you will see this, but occasionally you'll run into that, okay? You guys know what the atomic number is, you know what the chemical symbol is, you know what the atomic mass is. We've already talked about the periods and the groups. Let's go. Main group is basically the ones that have the A's on it. Come on. Oops. Okay, so we know that our periodic table is broken down into transitional elements, which are transitional metals. So let me pull up my periodic table so you guys can see it at the same time. Okay, you see P table? Okay, so let's see how much you guys know. Okay, what element is in group 13, period 4?
Oh, sorry. Gallium.
Gallium.
Gallium. Okay, and what is its atomic number?
31.
Okay. Is it a metal or non-metal?
Metal.
What type of metal is it? Is it a alkaline metal?
Post-transition.
Okay.
Post-transition metal.
Piece of cake?
After second pound, yeah.
Okay, so where is tungsten located? Give me the coordinates, period and group, and then tell me, is it a metal or non-metal?
It's period 6 and group 6.
Group 6, period 6.
Okay,
Transition metal.
and it's a transition metal.
Yeah.
Okay. Let's see. Where is phosphorus located?
Group 15, period 3.
Period 3. Group 15.
Group 15, okay.
Period 3.
And it's a
And what is it,
non-metal.
metal or non-metal?
A non-metal.
Non-metal.
Okay, so who's in group 2, period 5?
I can't even say that.
Strontium.
Rhodium.
Strontium?
Strontium.
What? Group 2, period 5?
Group 2, period 5.
Strontium?
Strontium, okay. What is it? What type? Is it metal or non-metal?
Alkaline earth metal.
Alkaline metal?
It's a
It's an
metal.
alkaline metal.
There.
Okay, what's in group 1, period 1?
Hydrogen.
Is it a metal or non-metal?
Non-metal.
Okay, piece of cake?
Yes.
But
Kinda.
we're supposed to know what they are.
Yeah, you should.
So what kind of question would you ask us in the periodic table?
I would ask you what I just asked you.
Oh, just like that?
Yep, just like that.
Oh my God.
So can you tell? I mean, it's really easy to tell. If you can't tell what's a metal and non-metal, I'm a little worried. That means you're not reading anything, right?
Should I drop the class?
What did you say? Oh, you can't drop. I already told them.
I'm saying, should I drop the
I
class?
said, Mr. Farmer, I said, if Mr. Farmer comes, I said, don't let him drop. Mr. Farmer can't drop.
Oh.
I already told him.
You can tell on the ones that are colored, but ours are not colored.
We'll print out a colored one.
Oh, we can do that? Okay.
Yeah, this has
Dr.
print.
Henry?
If you go here, you press print. Come here, you go periodic table, and there you go. Beautiful color.
Wait, where'd you get that one
Damn.
from? That one looks way better than mine.
It's the one that he printed.
I have this one. It's like, I can't even read the.
Oh, you got the boo-boo one. Just joking.
Which one is this one? Dr.
Want me
Henry.
to send you the link? I'll send you the link.
Please.
Yes, please.
That's not boo-boo. This is boo-boo. This has no color.
Oh, yeah,
That
hers
one
is
is
boo-boo.
This
This
one,
one I cannot find on Mado here.
I got the one the teacher uses on the screen. This one.
Okay, yeah, I need that one.
There you go.
They look like I cannot find non-Mado here. I don't have it.
It doesn't tell you.
So is it? Oh yeah, I like this one. Oh yeah.
This has all the answers.
How do I?
Okay.
Wait.
And also be sure the metalloids, because the colors of metalloids and the post-transitional metals are kind of close. So be sure that you can distinguish between the two. Okay.
I just noticed something where we can distinguish between the difference. The metalloids have an M on the right.
That's right.
Bottom corner.
That is right.
The what? The metal what?
Metalloids.
Metalloids. If you look at number 32, on the bottom, there's an M for metalloid. And if you look at 34, it has an N for nonmetals at the bottom right corner.
You right. You're right.
Be beautiful, isn't it?
It's amazing.
See, that's why I love that periodic table. P table is bomb.
Dr. Henry?
Yes.
So on my periodic table, it doesn't have that option. It just has everything in color. So for mine, the purple was the other metals, and then the one that's like a green is like the non-metals.
Uh-huh.
Is there a distinctive name that you're gonna put on the exam for them, or just other metals and non-metals?
You know, you'll get metalloids, so you need to be able to distinguish between your metalloids. So what I would recommend you do, I strongly recommend that you print out the P table one. The link is in your chat box.
Okay. So don't look at this periodic table then.
Well, you can look at any periodic table, but I mean, you know, you want to have the one that's going to give you the most bang for your buck, right? So if somebody's giving you a Porsche or a 1957 Get Out and Push, which one are you going to go with?
Porsche.
I'll go for the Porsche.
Okay, I would hope so. If you said otherwise, I'd worry about you a little
Which
bit.
one's paid off? I'm just.
Okay, let's see. Okay, so let's go back to the presentation.
I think I lost you guys. I can't. you guys.
Okay. So list the atomic number, chemical symbol, and the atomic mass of the third period element in group 16.
Third and 16.
Group
Sulfur.
16.
Selenium?
Wait.
Argon?
Wait.
Okay.
Wait,
Third
period 3, 16?
Okay.
Sulfur,
Yes.
right?
It's sulfur.
Hold on, period.
Oh, I went all the way down to 18.
Okay, so the atomic number is 16.
16.
Atomic number 16. And the atomic mass?
Atomic mass is
32.064.
54.
Okay. Piece of cake?
No, wait, hold on. You
Wait, what
said
was it? What was the atomic mass?
For sulfur.
no. My question is, you said 16, so it'd be row 16.
I said group. No, I said group 16.
Oh, group. Sorry, group.
Don't put words in my mouth. Look at you. Already putting words in my mouth.
Sorry, I was listening to you and my kids at the same time. So, let's see, group 16. Okay.
And the third period.
Third period.
It's because you said the period first this time, so I kind of threw people off.
I was like,
Well, so you got to be prepared, right?
The top is
I'm
group.
deaf.
Period.
Come on, adaptability. That's part of being a good nurse or a good doctor or a good pharmacist
Anything.
or, got to be adaptable.
So the atomic mass would be 32.06?
Yep.
Okay.
And you guys will have some slight variation depending on the periodic table that you use, okay? So don't get too hung up on that. Okay, is it a metal or non-metal? Or metalloid?
Sulfur is a non-metal.
Non-metal.
Non-metal. Piece of cake?
Yeah.
Okay. Let's see. What about, give you guys one more for the road. Let's see. It is in the fifth period. So list the atomic number, chemical symbol, and the atomic mass of the fifth period element in the 11th group.
It's silver.
Silver.
47.
Silver, 7, AG.
And mass 107.87.
Okay, you got it, right?
So question again, Mr. Henry. Dr.
Yes.
Henry. The S? Oh. Symbol S? No, 5. Oh, okay.
I was like, why is the atomic number 16? But it's not right.
I get
It's
it.
107.87. I was
You guys get it? Simple?
Yeah.
Okay, I'm gonna ask a question that you had already answered. Like, so the left column is the period, and then the top numbers are the group.
That is correct.
Okay, I heard you said. I'm trying to get like confirmation.
Okay. Okay. Are you guys ready for more? You want more, right?
Yes.
Okay, good.
Yeah.
Let me put my glasses on.
One more for the road. Let's see. If we have, so list the atomic number, chemical symbol, and the atomic mass of the element in the fifth period, 14th group, or group 14.
Is it 10? SN?
50.
10.
Atomic.
Atomic number 10. No, 50 actually.
Atomic weight is 118.71.
And it's a post-transition metal.
And
It is a post-transitional metal. Piece of cake. right? So these are like 3 points. These are giving me points, right?
It's calling it now.
Okay, so in this table, these are the most commonly used elements that we talk about. So you need to make sure that you're getting these, you don't memorize them, you want to learn them, right? And this is just showing those guys. Questions, concerns, Cash?